Okay, today is 9th of June 2017. I'm glad to welcome the class. There's an echo coming in now. I don't know whether. Okay, so welcome again, and I will want to say that this lesson or this class, this seminar, will start with Busayo. He'll make his presentation on Core i7, and then Ademola Lawa will be next, and then we'll take it from there. So, Busayo, if you are ready, you can start your presentation.
Okay. Good evening, everybody. Good evening, sir.
Yes, good evening.
Yeah, today I'll be presenting on the futures of Intel Core i7 and its importance in computer science. And on my slide, on slide 4, where I have introduction. Now, the Intel Core i7 belongs to the family of the processor of the Intel. Now, the Intel Core i7 firstly introduced what we call the memory controller. Now, an element that actually supervises the memory input and output. But in some other Intel Core, the memory controller supports 2 channels. But in the case of the Intel Core i7, it supports only 3 channels. And it actually makes use of the double inner memory module. Now, the Intel Core i7 has certain features that distinguish it from other Intel Core. Now, the first, I have that on my slide 5. Now, the first feature is high performance with QPI. High performance with QPI, that's quick path interconnect. Now, not only was the memory controller moved to the CPU, now the Intel Core i7 also introduced a distributed shared memory. If you look at the diagram, you have what we call the distributed shared memory architecture using the quick path interconnect. Now, if you look at that diagram carefully, now the architecture includes memory controller integrated into the microprocessor, which are connected together with the high-speed point-to-point interconnect. That is from the diagram. Now, apart from that, now it also provides that is a quick path interconnect. Also provide a high bandwidth and a low latency. Now, this feature actually allows the Intel Core i7 to provide reliability, availability in enterprise application. Now, let's go to slide 6. Now, the improved cache latency. Now, due to the fact that if you look at this diagram, you have L1, L2, and the L3 cache. Now, due to the fact that the L2 cache was not suited for a quad-core architecture, now to solve the problem of this, Intel Core i7 was actually provided with the L2 cache. If you look at the diagram,
yes.
L2 cache. That happened is because of high performance and high latency and low latency. Now, the level 3 cache doesn't operate at the same frequency with the L1 and the L2. Okay, so but the L3 cache also also allows variety of application to run. In fact, even including the test, measurement, and control for computer scientists. Now, on slide 7, now
yes.
the turbo boost technology. Now, that's one other feature of the Intel and AMD actually introduced what we call the multi-core CPU. Now, since then, a lot of application and development have been upgraded to take advantage of multiprocessing. But the advantage of Intel Core i7 processor having turbo boost is an ability to increase the performance of the processor and to optimize power consumption. And it also allows the processor to run faster than any other Intel Core processor. And that's one of the key features of the Intel Core i7. Now, another one is the Intel Core i7 produced a new platform architecture. That is on slide 8. It provides a new platform architecture. Now, if you look at the Intel Core i7 processor, now formerly the processor core had FSB, that's the front side bus. But the Intel Core i7 comes with the elimination of the front side bus. Now, in some other Intel Core, it was actually replaced with the direct media interface, that's DMI. But for Core i7, the front bus was actually replaced with a quick path interconnect, which I just explained in my first part. Now, we also have on slide 9 where I have my iPad threading. Now, iPad threading is a technology which allows a single processor to act like a 2 separate processor. which allow them to share the same physical resources. Now, there are some computational problems that actually requires this technology of hyperthreading to solve a variety of problems. For instance, mathematical and engineering method in computer science actually requires this technology of hyperthreading. Like that's one of the areas by which we can apply the hyperthreading. Now, lastly, I have visualization, improved visualization. That's one of the key features in the Intel Core i7. Now, this is actually a technology that enables running of multiple operating systems side by side in the same processing hardware. Now, this feature of visualization also allows computer scientists, engineers to build capable and complex systems for test, measurement, and control. I think these are just the features of the Intel Core i7 and their application. Thank you, sir.
All right, thank you very much, Busayo, for a very well presented paper on Core i7. What I know you missed is to have a last slide which contains your references. I'm sure, no problem. That's just fine.
Yes,
So can we take questions for Busayo? Lawal?
No questions, sir.
Okay, Jeremiah?
I don't have any questions, sir.
Johnson?
No questions, sir.
Bilei, are you online?
Yes, sir, I'm online, sir.
Yes, so do you have a question for him?
Question that I want to point out, like, why is he using the small letter for the Intel on slide 8?
Slide 8?
Yeah.
Slide 8 are using small letters for the Intel.
Yeah, I think it's just an error. Just an error. I don't know which one is a slide 8. It's an error. Yeah, okay. Thank you. For me, what is the next? What is the next generation? You talk about the 7th generation, 8th generation of Core i7. Now, what is in the works for Intel? What is Intel planning next? You know, we had a Core i3, Core i5, Core i7. What's Intel planning next? Yes, Busayo.
Okay. Sir, no idea, sir. No idea.
Okay, very well. Now, there is a forthcoming generation. Actually, it's on now. Forthcoming generation of processors that will beat all of these ones flat. I need you people to research it, and then we'll talk about it in the next class. It's amazing architecture and amazing performance. So you look it up, and we'll discuss it next class. So now let's move on to Ademola Lawal. Lawal, so you have the floor to present. I think you're presenting on something we had before. Internet of Things, that's fine. Let's see where you're... Yes? IoT.
Yes, sir.
Yes, so please go ahead and present. You have 8 minutes.
Okay, so I'm presenting on Internet of Things. Actually, based on our previous knowledge and the previous speakers on Internet of Things, we all understand that Internet of Things is actually the interconnectivity between things on the internet. Like on my first slide, on my second slide,
Yes.
I tried to put the definition of the Internet of Things. But according to my research, there is no exact, precise definition of Internet of Things, but everybody
Okay, your connection, your internet connection is also... Okay, go ahead, yeah.
Okay, sir. The Oxford Dictionary actually defined Internet of Things to be the interconnection via the internet of computing devices embedded in everyday objects, enabling them to send and receive data. So it means Internet of Things is just actually all types of gadgets that are being connected on the internet. So on my slide 3, I tried to list the features of the IoT, which are one, the artificial intelligence, connectivity, sensors, active engagement, and small device use. Now I'm proceeding to the slide 4. I tried to elaborate on the artificial intelligence, which is just trying to make everything in such a way that the internet is going to provide a solution to everything that we are, to all our problems in a kind of electronic way. So there is an illustration there that says that, okay, it means that when you have food in your fridge and you are out of there, and artificial intelligence will only prompt you that, oh, you are running out of this and you have to just purchase it. Artificial intelligence is just a kind of innovations that make us to discover things electronically. So on my slide 5, I try to talk about connectivity, which is actually the basis of Internet of Things, because if all things are not linked together on the internet, all components will stand on their own, and there will not be communication between all peripherals of the device all around the world. So I'm going to slide 6, where I talk about sensors, because without sensors, IoT is actually useless, because sensors is actually the connection. It's defining instrument which transform IoT from a standard passive network or device capable of real-world integration. Because without the sensors, all the components, or let me say all other networks all around, will not have this interconnectivity between each other. Moving on to slide 7, I talk about active engagement. Much of today's interaction with connected technology happens through passive engagement. IoT introduces a new paradigm of active
my friend, a new paradigm, not I cannot wait to correct you in that. A new paradigm. Say that twice.
Okay, paradigm.
Yeah,
Paradigm.
good. Please go ahead.
IoT introduces a new paradigm for active content and product or service engagement. So IoT
Yeah, your voice is getting wobbly now.
to passive device use will give the opportunity to link up devices to make it useful on the network. So now, the Internet of Things communication model, I want to explain them bit by bit. The first one is device-to-device communication. The device-to-device communication model represents two or more devices that
Yeah. Okay, since it's getting wobbly, I'm going to take control. Yeah, so device to device is getting wobbly now, Ademola. Device to device communication, device to cloud.
Device cloud communication. Device cloud communication. In device cloud communication model, the IoT device connects directly to the internet, into the internet cloud service, like an application service provider, to exchange data and control message traffic. So that's about the device to cloud communication. The next one that we have is device to gateway model. In device to gateway model, the device to application layers gateway model, the IoT device connects through an ALG. The ALG is the intermediary between the device and the server. So that's about device to gateway. The device has to access a gateway before it can actually resource and get an information from the server. So the last one on the model that I have here is back-end data sharing model. The back-end data sharing model. The back-end data sharing model refers to a communication architecture that enables users to export and analyze. So that's about the models of the IoT. So I want to move over to slide 10. In slide 10, I'm trying to explain how the Internet of Things is transforming education. Like, Internet of Things is actually contributing a lot to education these days. And the advent of the distance learning, the Open University, is as a result of the Internet of Things, trying to link up the instructors, the lecturers, together with the students, and also together with educational resources on the internet, is actually part of the uses of the Internet of Things, the contribution of Internet of Things to education. On slide 11, I talked about institutions trying to improve the educational outcome by providing richer learning experiences, by getting real-time, actionable insight into student performance. With Internet of Things, we have e-learning applications that the students can actually use to study on their own, so that it will reduce the weight, or let me say the workforce, or the workload on the side of the teacher, to make the work more lighter for them, and again, to create an enabling environment for the students to actually access the internet and also get resource from it. So on slide 12, I talked about improved operational efficiency. Educational institutions are comprised of many moving parts. Like, we have many departments in all educational settings. So in order to succeed in what they do, they must be able to keep track of students, staff, and resources at the lowest cost possible. So tracking devices can ensure that students are accounted for in real time. I explained better on this in other slides. So let me proceed to slide 13. The Silver Campus device. I said officials are under increased this is more important than ever to give the IoT ability to track objects, students, and staff, and to connect devices across campus, bring a new level of safety to institutions. Like now,
Begin to round up. Begin to round up in 2 minutes.
Okay, so let me proceed let me just explain on that. So now, when we have some tracking device that we can actually use to supplement the normal entry that we use in the secondary schools of nowadays, where we have to take attendance of students. If the students can have a sort of tracking device or some sort of technology that once they board the school bus going to school, the school can actually mark their attendance immediately with some technologies. So the IoT in the next future will actually take over this, and it will provide for enabling society. It will actually provide a more secured environment for learning, and again, we improve our learning content, whereby students can actually access the internet, and again, to reduce the workload on the side of the teacher. Then the administrative
One more minute.
Okay. In the administrative part, it will also help the admin in keeping records and keeping track of the progress of both the students and the teachers, and also the educational content and the educational goal itself. So I'm rounding up on the IoT, sir.
Thank you very much, Ademola Lawa. As always, that's a very good presentation. Let me now ask the class to comment or ask questions or make observations. Yes, Busayo.
Sir?
Yeah, Jeremiah.
I don't have any questions.
Okay, Johnson.
No questions.
Okay, Billy.
My question is on slide 3.
Oh, yes. Slide 3.
Slide 3. You said on slide 3 the IoT specifically for small devices. I want to ask you, is there no room for bigger devices like a car or water tank?
Okay.
Very good question. Yes.
An answer to that question. It's not as if there's no room for big devices, but the IoT is incorporating small device use nowadays, whereby I talked about GPS trackers. GPS trackers are very minute in nature and can be incorporated into maybe the student's ID card or into a wristwatch of some sort. So I'm just trying to say that IoT is trying to incorporate small device use, like the small device that we use every day is trying to bring in a relevance of those devices into using them for a bigger mission.
Okay, the straightforward answer to Bile's question is that regardless of the object, small or big, a refrigerator or a car, the Internet of Things will interplay there. I know that Bileyi, because he presented on Internet of Things, he knows that that's the answer. But because you indicated on that slide that features of IoT, small device use. So it's small device use, big device use, any device use. Bileyi, I'm sure that's the answer you are expecting.
Yes,
Very good. So I like to just
sir.
commend you. I don't have any specific question other than it has helped to strengthen or collaborate what we learned in 2 lessons back. That's on the 6th of June, I think, 6th or 7th of June 2017 on Internet of Things. So very well done. Bileyi, are you sure you're going to take your lesson now? Your paper now?
Yes, sir.
Okay, just hang on a minute. Okay, Bileyi, if you are ready, let me go grab your file and we'll like to listen to you as always. Let's see. What are you presenting on today?
Features of Intel Core i7 processor
Oh
and
yeah,
its
that's
use
fine.
in
I think
computer
I
science.
I think I got your file. Let's see. This is Busayos. Features of Core i7. Let me grab it from the. Yes, I'm able to get your slide. Bileyi.
Yes, sir.
Yeah, just 1 minute. So you can just keep going on it. Just a second. Yep. Okay, so you have the floor, Bileyi, to present.
Thank you very much. Good evening, all. Core i7 processor and its use in computer applications. I go straight to slide 3.
To slide what?
Of the processor.
Slide what?
3.
Okay, that's fine. Go,
Slide
go ahead. Go ahead.
processor is a logic circuit that responds to and processes the basic instructions that drive a computer or simply the brain of the computer. An Intel Core i7 is an Intel proprietary processor that is built on the framework of a multiprocessor architecture. That is just a brief definition. I'm moving over to the 4th slide, which gives us the type of microprocessor, which are basically on 3 types on the architecture. That's 6 RISC and superscale microprocessors. I move over to the evolution of microprocessors. In there, you will see the first one is 4004, and an arrow is pointing to the recent one that we are talking about today. But in that same slide, the various evolutions of microprocessors can be seen from the Intel 4004 to Pentium and to the Core series. I'm moving over to the next slide, which indicates or highlights the various features of Intel Core i7. From the day it was invented in 2008 to the clock speed, the dual core processors, the logical processors, the L3 cache has been introduced and changed a lot of things in this processor. Then the high-end processor series comes with a support of overclocking, wide range of gaming in laptops. I move over to the next slide, which also gives us further features of Intel Core i7. You will see there that we have 4.306 gigahertz cores for better multitasking and multi-threading performance. Also highlighted there we have 8 mega of smart cache. Also highlighted there we have limited memory capacity, high memory bandwidth, and the last one, quick path can connect to provide faster data between the processor and the internet. Now to the explanation of some of the points highlighted earlier. New platform architecture. On this part, you see that the the Intel Core i7 has been able to build from the last, which is the high core 5. Included the CPU, the graphic, the memory controller, or also known as the NOT bridge, and an input, also known as the South bridge. This has enhanced it from the previous generation, which is the Core i5. And I quickly want to move over to the next one, which is the high performance multiprocessor system. Not only was the memory controller moved to the CPU from Nehalem processor, Intel has also introduced a distributed shared memory architecture using the QPI. This new point-to-point interconnect for connecting a CPU to either a chipset or another CPU. It provides up to 25.6 giga per second of total bidirectional data throughput per link. Another basic feature that is in this Core i7, Intel Core i7, is the CPU performance boost via Intel Turbo technology. On this part, you will see from the slide that before the advent of multi-core CPUs, this application saw performance gain by exceeding new CPU that simply offers high clock frequency. But with multi-core CPUs, the trend was broken as new CPU offers more discrete processing score rather than the higher clock frequency. I'm moving to the next slide, sir, which is slide 11.
Yes, good.
Just that page is giving us a typical diagram of what I have explained in the last slide. Intel Turbo boost features offers processing performance gains for all applications regardless of the numbers of execution. You will see the first one on my right hand side, the single turbo. The frequency is just single. While the dual core turbo mode, you have a dual core turbo, and the next one quad core.
Can you call it quad rather than quad? Sorry, can you call it quad? Quad, yes, rather than quad. Yes.
Quad core turbo mode. And the last one, which is quad core base frequency. See, there we have the frequency is higher there to tell you that it has gained a lot of performance against the trading created. Then the next slide, sir, which is slide 12. Are we there?
Yes, we're there. Carry on. Yes, carry on.
He's talking about the i7 family, which is an increasing L3 that helps to build up 12 megabytes inside. Figure below shows exactly what I'm talking about from 0, 1 to the third one, and inclusive share. On this part of you will see that the kilobyte for instruction, for the first one is 32 kilobytes, the second one is 256 kilobytes per second. One side, the third cache is 8 megabytes. I'm moving over to the next slide, sir, which is slide 13.
Good.
Virtualization performance. Virtualization is a technology that enables smooth running multiple OS side by side on the same processing hardware. Gone are the days whereby we have different hardwares processing at the same time, but it's very easy for test, measurements, and control space, which can be used by engineers, educators, and scientists. I'm moving over to the next slide.
Yes, go ahead.
That's slide 14.
Good.
Uses of Intel Core i7 in computer science education. I'm picking from the ideal for test for my last slide. Ideal for test and memory. The new Nehalem microarchitecture, Intel moved the memory controller and the PCI Express from the north to this, which I've explained earlier, reduced the numbers of external ports that the data to transfer. This will help computer scientists, engineers, or administrators to increase their data input and reduce the latency for memory based on any kind of program they want to run in the class or in the offices. I'm moving to the next slide.
Yes, go ahead. Go ahead.
enhance design simulation hardware. As a computer scientist, we know that very relevant that most of the things that are virtual relevant or that are difficult to explain to students in any of the other pieces of STEM. But with the help of simulation, which the Core i7 has been able to help through the multiple CPUs, examples of these types of application range from every student and lecturers, biology, chemistry department to design simulation with hardware in the loop. The next slide, which is slide 6, improve virtualization performance. Intel has added new features such as hardware and table and direct input output in the core i7 processor and chipsets that allow software to further improve their performance in visualization environment, whether in the class or in seminars or in programs that you want to enhance the understanding or the attentiveness of students in general. So the next slide, sir. That is slide 18. This processor is ideal for computer 3D. There are some top class, whether in higher institutions or in colleges of education, that are seemingly very difficult for teachers or lecturers to make it clearable or to make it very easy for students to understand. But with the help of the 3G, the multitasking and multi-threading application that come with the Core i7, it has taken a very simple for teachers to pass to the students. And my last slide is the speed you need computer science education of internet of everything. We know everything that we have to do in computer science or in science and tech requires quick reaction. But with this Intel Core processor, it has been able to help us to bring up software to activate anything we want or multitasking program that will make the class interesting and to increase attentiveness in class. And my last slide is just my references. Thank you for listening.
Thank you so very much. Let us applaud all of those that are presented today. I really have enjoyed your presentations. So let's have questions for Gbile Iyadu. Demola Lawa, what questions do you have for him? Or if you want to add to it. Very well. Busayo.
Yeah, I also asked, does the Intel Core i7 does it have a processor graphics?
Yes.
The Intel Core does it have that GPU, that processor graphic, that graphic processing unit? Does it support that feature? Does it have that particular feature?
Yes, Gbile. We can't hear him now. So Jeremiah, any question for him?
Sir, I have a question for him, sir.
Pardon?
I just want to ask.
Yes.
Hello, sir.
The Core
No, Gbile, there's a latency in your response, so just hold on a little bit. Add on that of Jeremiah to it. Jeremiah, yes, carry on.
The question I have for you tonight, I want you to talk more on, just give us an insight about, because we've been hearing about Core Intel i9. So I just want you to give me an insight about Intel Core i7, then linking me together with Core i9 that we are expecting, because there's a lot of discussions that there's going to be extended and so I'm expecting Intel Core i9. So you relate it to Core i7 that you presented.
All right, thank you. Have you presented on Core i7, Jeremiah?
No, sir.
Fine. Don't answer the question. Whether the man has not presented anything, so let him present. Add it to yours when you are presenting. Johnson, any question for him?
No,
all right, that's fine. So, Gbile, you were trying to answer the question by Busayo. Can you deal with that now?
Yes. Can you hear me now, sir?
Yes, we can hear you. Can you hear him, the class?
Yes, I can hear.
Okay, that's fine. So, go ahead here.
One of the beauty of the features of Core i7 processors is that apart from the DDR3 memory that is supported, the PXI that is supported, one of the high performance multiprocessor that is supported is that it includes the GPU for graphics. So it enables you to work any length and with high speed to get whatever you need that has to do with anything related to graphics.
Okay, fine. Busa, you're satisfied with that because we're going to end the class in a little while. Are you happy with that? Okay, thank you.
Yes, sir.
Now, I'd like to thank you all. You have done very well. I'm highly impressed with your class. Recall that I keep mentioning that your class is one of the best that I've taught for the Masters in Computer Science Education class the last 25 or so years. So very well done. We are missing, I think, Ugokwe. Please let her know that she's you know the rule of the game is that if you miss two classes, then you're out of it. She has missed two or so already. Please warn her that if she misses the next one, and the next one is when Sunday night, is it?
Yes, sir.
Okay, Sunday night. I just returned from Accra, as I mentioned to you. I'm back in Lagos. I'm going to run. Are you attending the advanced statistics class tomorrow, Billy?
Yes, sir.
Very good. Now, those of you who are free, if you want to attend, it's very important. Tomorrow, advanced statistics class, I'll be looking at discriminant analysis. You got my mail. Billy, did you get the mail?
No, sir.
Okay, fine. So I can forward the mail to you. We'll be looking at discriminant analysis, looking at canonical variate analysis, and cluster analysis. These are very important tools for your research. Knowing that I do not think you want to be satisfied with just taking a master's degree. You want to proceed to take a PhD. And you'll be needing these important statistical tools for your research. So if you're able to make it, we're starting at 12 noon tomorrow and we're finishing at 5. Immediately after we finish, I have a meeting UNESCO headquarters in Paris. So I'll be, flying out tomorrow to London and then to Paris. So I'll be connecting with this class from Paris Sunday night at 8 o'clock. So have a wonderful evening, all. Enjoy the rest of your Friday. I'm sorry I had to move the class by about 45 minutes because I just arrived from Accra and I had to come, calculated that I'll be back home at this time. So that's why I shifted it. But I'll be arriving in Paris on Sunday at about 5 p.m., back in the hotel at about 6:30. So the 8 o'clock is fine by me. And we're keeping the same time with Nigeria. So once again, thank you for the good work that you all are doing. And I wish you a fine evening. So good night.
Bye-bye,
Nice,
sir.
sir.